Welcome to Respiratory Protection, Competent Person. Washington State requires this training for workers in WAC 296, Chapter 842. Our company's respirator program manager is the safety manager. Respirators can save our lives or our long-term health. We need to wear respirators in the following situations: when chemical, permissible exposure limits are exceeded, in an oxygen-deficient atmosphere, when required by a pesticide or chemical label, when required by our company policy, when respirators required signs are posted at the workplace, when dusts, mists, or fumes are present, and for all unknown respiratory hazards. This course will help you have the knowledge, understanding, and skills to safely use respirators. Respirators are not our first choice in protection from chemicals because they have limitations. They can leak, wear out, or be the wrong kind of respirator. They can be hot, uncomfortable, and make it hard to see or communicate. They can be hard to breathe through, and they are easily removed in contaminated air, but they can still save our lives. Because it would be better not to use a respirator at all, how can we avoid wearing a respirator? OSHA helps us out with a chemical safety hierarchy of controls. We can implement the most effective to the least effective ways to reduce exposure to airborne chemicals by eliminating the use of toxic chemical, substitute the chemical with a less toxic chemical. Use engineering controls such as ventilation and dust suppression with water. Isolate or enclose the chemical processes. Implement other administrative controls. Respirators should be used only if these other methods are not feasible or don't reduce exposure. Air purifying respirators. In this training, we will discuss several types of respirators. First, we will cover air purifying respirators. These respirators filter air in the space through filters, cartridges, or filtering face pieces like dust masks. A type of air purifying respirator, powered air purifying respirators, or PAPRs, filter room air through cartridges with assistance of a blower. We will briefly mention the purpose in using supplied airline respirators and self-contained breathing apparatus for oxygen, deficient or toxic atmospheres. This picture shows how air moves in and out of the respirator. The act of breathing creates a negative pressure inside the mask, which is why these and dust masks are sometimes called negative pressure respirators. Air goes in through the inhalation valves on the sides, which are filtered by cartridges and filters in front of them. Air is exhaled out the exhale valve in the front. If the mask does not seal properly along the edges, contaminated air can enter during inhalation. Filters stop particulates. Filters work by air moving through a series of microscopic mesh that traps particulates bigger than the holes in the mesh. A P95 filter is 95% efficient to 0.3 micron. A E100 filter is 99.97% efficient to 0.3 micron, also called a HEPA, or high-efficiency particulate air filter. These are usually color-coded a magenta color from most filter manufacturers. The N designation stops solid particulates and non-oil aerosols that do not degrade filter performance. The P designation stops solid particulates and degrading oil-based aerosols. P filters have no use limitations other than those normally associated with particulate filters. An N95 filtering mask is a respirator. If you are required to wear an N95 due to an occupational exposure, you must be trained and fit tested. N95s can be used for protection against viruses like COVID, nuisance dusts, and wildfire smoke. They cannot be used for protection against environmental hazards like lead, mold, or silica, or in oxygen-deficient atmospheres. If you are required to wear an N95 due to an occupational exposure, you must be trained and fit tested. Respirator cartridges are designed to provide protection from specific gases and vapors. Chemical cartridges can absorb chemicals without airflow. They work similar to baking soda in a refrigerator, absorbing gases and vapors in their vicinity. Cartridges only work to protect you from the gases and vapors they are designed to absorb. Cartridge styles may also vary based on the respirator face piece style. Cartridges may accept filters with adapters or be combined into a cartridge filter unit. Cartridges and filters have vastly different use times, and the combination units may be unnecessarily expensive. Cartridges for respirators have a limited service life. When a gas or vapor that goes through the chemical cartridge into the facepiece, it is called breakthrough. If you smell the chemical with your respirator on, you should know it is not working. If a chemical has no odor, or it can only be detected at high levels above the permissible limit, you may not know if your respirator is working properly. For these reasons, cartridges must be changed regularly. Next, we will cover respirator program requirements. Our respirator program contains the following information: the identity of the respirator program administrator, workplace-specific written procedures and records, proper respirator selection criteria, medical evaluations procedures for respirator users, fit testing requirements for respirators for each user, respirator maintenance, repair, and storage requirements, assured air quality for supplied air respirator use, and employee training requirements. Our respirator program contains the following information: the identity of the respirator program administrator, workplace-specific written procedures and records, proper respirator selection criteria, medical evaluations procedures for respirator users, fit testing requirements for respirators for each user, respirator maintenance, repair, and storage requirements, assured air quality for supplied air respirator use, and employee training requirements. Because respirators can create additional demands on the body, it's important to make sure we can safely wear a respirator. The first step in this process is a medical evaluation. It is a confidential medical questionnaire. You will receive the form and need complete the questionnaire and return it to Respiratory Program Administrator. They will forward the information to the physician or other licensed healthcare professional, PLHCP. The PLHCP decides if you can wear a respirator or an additional medical exam is needed. The results of the medical questionnaire are only used to determine if you can wear a respirator. The information in the questionnaire and the medical exam can't be shared by the medical provider with anyone at our company. Your company will only get a notice stating if you can or cannot wear respirators. Respirators must fit properly to protect you from hazards. Fit testing must be done before first wearing a respirator and at least annually after that. Fit tests must be on each style of respirator worn in the size the user will be wearing. Tight-fitting respirators must fit properly to prevent leaks around the edges. Beards are not allowed when wearing a tight-fitting respirator because they will break the seal of the facepiece. Seal checks must be done before using respirators for protection. Perform both a positive and a negative seal check. Positive seal checks involve blocking the exhalation valve and blowing slightly into the mask. Negative seal checks involve covering the inhalation valves and breathing in. In both cases, the mask should keep a seal and not have air leaks. If you cannot perform a successful seal check, reposition the mask and try again. You may need a different size, style, or brand of mask if you cannot perform a successful seal check. There are different fit tests depending on the style of your respirator. These are called qualitative or quantitative fit tests. Half facepiece respirators and N95s may use a qualitative fit test such as an irritant smoke test or Bitrex, TM. Full facepiece respirators must use a quantitative fit test process using an AccuFit TM, PortaCount TM, QuantiFit 2 TM, or similar fit testing machine. Follow the fit test protocols in WAC 296 for employer-provided fit testing. Let's dive a little deeper into the technical definitions for respiratory protection. Chemical exposure limits can be quantified by using the following terms. Permissible exposure limits, or PEL. The PEL is the amount of an airborne chemical, toxic substance, or other harmful agent that must not be exceeded during any part of the workday. If airborne levels cannot be reduced below these limits by other means, respirators must be provided to protect exposed employees. An airborne chemical or toxic substance can have 3 PEL values, TWA8. This is an 8-hour, time-weighted average limit. Short-term exposure limit, or STEL. This is typically a 15-minute, time-weighted average limit. Ceiling limit, This is an instantaneous limit, meaning when you hit this exposure level, you must use a respirator immediately. How do we determine a time-weighted average TWA? Complete an exposure assessment with air monitoring equipment. Divide the exposure per hour by the hours worked. If the result is above the PEL, additional engineering controls and respiratory protection is required to reduce the exposure below the PEL. What does IDLH mean? Immediately dangerous to life and health. This level of exposure causes an immediate threat to life, can cause permanent or delayed adverse health effects, or can interfere with an employee's ability to escape. Most chemicals have a listed IDLH level in the NIOSH IDLH table. You can click on it to follow the link. Oxygen deficiency is also considered an IDLH environment. IDLH conditions can occur in confined or enclosed spaces, from large chemical spills or leaks, and during fires. Some toxic chemicals are PELs are expressed in parts per million. To illustrate, 1 part per million, or 1 milligram per liter, mgl, think of putting 1 drop of water from an eyedropper into 10 gallons of water. The PEL of other chemicals might be expressed with an unfamiliar symbol, the microgram. This is an example of the PEL of lead, 50 micrograms per cubic meter. To illustrate what that represents, in a 1 gram packet of equal, there are 15,543 grains. Imagine the poor intern that had to count those in a lab. So a milligram would equal about 15 grains, and a microgram would equal 0.015 grains. So 50 micrograms is 77 of a grain. When you see visible dust when working with lead-based paint, it always means you are over the permissible exposure limit for lead. How we select the correct respirator, cartridge, or filter. Why do we wear the respirator we do? Understanding how respirators are chosen is critical to your safety. You may have been handed a respirator in the past and told to wear it during a certain work process. We want you to do more than just wear a respirator. We want you to understand why you are wearing the respirator you are wearing. Respirators are not a one-type-fits-all safety device. The style, size, filters, and cartridges you use all make a difference. To choose those things, we need some data. First, what is the chemical or hazard we are protecting ourselves from? We may get that information from an SDS, air monitoring, or we may see dust in the air. Knowing the chemical or hazard will determine if we need a respirator with a filter for particulates, a cartridge for vapors, or a combination of both. Some hazards require supplied air respirators because they are so toxic. Once we know what the chemical is, we need to know how much of the chemical we are being exposed to. This is often done with an exposure assessment. We then compare that to the permissible exposure limit. If we are under the PEL, we may not need a respirator. But if we are over the PEL, we need to choose a respirator from the assigned protection factor. Half face, full face, and supplied air respirators provide more protection in that order. Exposure monitoring for chemicals involves air monitoring for work that could reasonably be expected to exceed the action level of a chemical. Air monitoring must be done by equipment designed for that chemical, by an air monitoring pump with a collection cartridge. Air monitoring must be performed in the employee's breathing zone, based on an 8-hour TWA, but may be of shorter duration, done while employee is performing work that would expose the worker to the chemical hazard. The air monitoring data is then sent into a laboratory and compared to the permissible exposure limit to determine appropriate respiratory protection. You must provide affected employees or their designated representatives an opportunity to observe any monitoring of employee exposure to chemicals. How do you get information about the chemicals you work with? The best place may already be in your hand. Product labels are required to include the following under the GHS standard. They must have the following 6 things. 1. A product identifier. 2. Signal words that will help define how dangerous a chemical is. The signal word danger means the chemical is on the more dangerous end of the spectrum. The signal word warning means the chemical is on the less dangerous end of the spectrum. 3. Hazard statements describe the nature of the hazards of a chemical, including, where appropriate, the degree of hazard. 4. Pictograms illustrate the nature of the hazards. 5. Precautionary statements give recommended measures of prevention, response, storage, and disposal. This is where you often find respirator use requirements. 6. The name, address, and telephone number of the chemical manufacturer, importer, or other responsible party must also be on the label. You can also get information about chemical hazards from safety data sheets, SDS, and material safety data sheets, MSDS, for older products. SDS for chemicals give us more detailed information about what chemicals are in the product, what the hazards of the chemicals are, and how to protect yourself from the hazards. We must have a list of all chemicals in the workplace, and we must have the corresponding SDS for each of those chemicals. You can learn a lot from the pictograms on a label or SDS sheet. The 9 pictograms are the 3 health hazards. Pictograms are exclamation point, health hazards, skull and crossbones. The 5 physical hazard pictograms are gas cylinder, corrosion, flame over circle, exploding bomb. And the 1 environmental hazard pictogram is environment respirators only protect you from the first 3, the health hazard pictograms. There is a better way to determine respiratory protection and engineering controls. Exposure monitoring sounds good, but in the past, most of it had to be sent out to a lab to get results. On shorter duration projects, the work may be finished by the time the respiratory protection was determined by the air monitoring data. Employees cannot be left unprotected during exposure monitoring. So based on historical objective data, OSHA has determined appropriate PPE for certain types of work until exposure assessments can be completed. There is a relationship between PELs and respirator choice. When exposure monitoring shows the PEL has been exceeded in a worker's environment, they must wear a respirator designed to reduce the exposure to below the PEL. The assigned protection factor, or APF, of a respirator reflects the level of protection that a properly functioning respirator would be expected to provide to a properly fitted and trained user. For example, an APF of 10 for a respirator means that a user could expect to inhale no more than 1/10 of the airborne contaminant present. The higher the APF, the more protection it gives the worker. A half-face piece respirator is good up to 10 times the PEL. A full face protects up to 50 times the PEL. Supplied air full face piece respirators are good up to 1,000 times the PEL. Some powered air purifying respirators, PAPR, have protection factors of 1,000 times the PEL. For example, the permissible exposure limit of lead is 50 micrograms per meter cubed. A half-mask respirator with filter could be used up to an exposure of 500 micrograms per meter cubed. A full face would be good to an exposure up to 2,500 micrograms per meter cubed, and a supplied air respirator would protect workers up to an exposure of 50,000 micrograms per meter cubed. So in this example, air monitoring shows an exposure of 1,700 micrograms per meter cubed using a time-weighted average, or TWA, of 8 hours. Is this worker wearing the right respirator? Yes, a full-face respirator with a P100 filter will protect the worker up to 2,500 micrograms per meter cubed. The 3M Respirator Selection Guide can help select respirators, cartridges, and filters based on the chemical you're using. Most cartridges and filters are based exposures under 10 times the PEL and using a half-face piece respirator. The 5th column specifies filters and cartridges such as OV, organic vapor, and P95 filters. If the letter F in parenthesis occurs, this means a full-face respirator is the minimum respirator required. SA means a supplied air respirator is the only respirator that can be used with this chemical. Once you've used a 3M respirator selection guide or a similar system to choose a respirator, You should document your choice in your respirator program. Create a respirator selection chart for routine tasks based on historical data or exposure monitoring. The sample respirator selection chart here shows 3 activities and their related selections for the model, cartridge, and filter. It then shows the change schedule for cartridges based on work effort and temperature. Filters are changed daily or when they are damaged, soiled, or causing increased breathing resistance. Finally, if a cartridge or filter becomes plugged, wet, or there is breakthrough of a chemical odor, they should be changed immediately. Cleaning, maintenance, and storage. Follow our cleaning, maintenance, and storage procedures to keep your respirator in working condition. Respirator maintenance and repair are essential for proper functioning. Respirators must be cleaned, inspected, and maintained regularly. Take cartridges and filters off before storing and place in separate bags. If cartridges are left out, their service life will be reduced. Store respirator face pieces in a clean, dry place, preferably in a box or bag. Do not store respirators in work areas. Do not hang respirators by straps while in storage. We've talked about some very technical things when it comes to respirators. Now let's watch how all this comes together when we watch this video on respirator use.
Introduction. In many workplaces, the air you breathe can be hazardous. Potentially harmful dusts, mists, fumes, gases, and vapors. Breathing airborne contaminants can damage your lungs or cause other sickness or disease, even death. If engineering controls or other measures are not sufficient, you can help reduce your exposure to certain airborne contaminants by wearing a respirator. Each time you wear a respirator, you must know the proper fitting procedures and follow them carefully. Today, we will introduce you to the half-facepiece respirators made by 3M and provide training on how to both use and obtain optimal performance from your 3M respirator. If you still have questions about correct fitting procedures after viewing the appropriate segment for your respirator, review the information provided in the user instructions. Check the steps on the poster provided by 3M or see your supervisor. If you have questions regarding which respirator is right for your application, see your supervisor or trainer. We will be reviewing and instructing in the following 7 areas: use and limitations, inspection, assembly, donning, user seal check, removal, replacement and cleaning, replacement parts, use and limitations. To help protect you from certain contaminants in the air where you work, your company has selected a 3M half-facepiece reusable respirator for your use on the job. It was chosen based on the specific types of airborne contaminants and their concentrations in your workplace. It is important that you use only the filter or cartridge that has been selected by your employer. The effectiveness of a respirator depends on its filter's efficiency in removing contaminants and the ability of the wearer to achieve an appropriate fit. No respirator can be effective if it doesn't fit and seal properly to your face. It is critical that all edges of the respirator are flush against your face. If you have a beard or other facial hair or any other condition that interferes with the face seal, you cannot use the face pieces featured in this video. An additional segment demonstrates fit testing your respirator. In the U.S., OSHA, the Occupational Safety and Health Administration, requires fit testing to ensure that your respirator fits properly. It is your employer's responsibility to ensure that you receive a fit test when the respirator is first issued to you, and then at least once a year. You will only get the protection this respirator can provide if it fits you properly and you wear it at all times while you are in a contaminated area. Do not use your half-facepiece respirator for concentrations of contaminants which are immediately dangerous to life and health, are unknown, when concentrations exceed 10 times the applicable exposure limit, or in atmospheres containing less than 19.5% oxygen. If you have any questions about which respirator and filters are appropriate for your respiratory hazards, consult your supervisor or trainer. If you don't follow all of the instructions and observe the limitations for your type of respirator, you could reduce the effectiveness of your respirator and take a needless risk with your health. Inspection. Before each use of your half-facepiece respirator, inspect it for any signs of damage. Check the facepiece, gaskets, straps, and all plastic parts and valves for distortions, cracks, tears, and dirt. Your respirator will not function correctly, and your health could be jeopardized if your respirator has damaged or defective parts. If it does, replace them before using the respirator. Assembly. 3M half facepiece respirators are designed to be used with a variety of 3M bayonet attachment chemical cartridges and particulate filters. To attach the round 2000 series and 2200 series filters, align the opening on the filter with the facepiece attachment. Push them together and turn the filter clockwise 1/4 turn until it stops turning. Do not turn past the stopping point. Attach the second filter to the other side. When attaching rectangular 7000 series filters, simply align the line on the inside of the filter with the small bayonet lug on the facepiece. Push together and rotate clockwise 1/4 turn to stop. To attach the chemical cartridges, simply align the mark on the cartridge with the small bayonet lug on the facepiece and push together. Rotate the cartridge clockwise 1/4 turn to stop. Follow these instructions for the second cartridge. All 3M half facepieces feature a guiding mark to help users align filters and cartridges properly with the small bayonet lug. If your work environment requires both a chemical cartridge and a particulate filter, you may attach particulate filters to the chemical cartridges. To attach the 3M particulate filters 5N11 or 5P71, place the filter into the retainer with the printed side facing away from the retainer. Press the filter retainer firmly onto the cartridge until it locks securely. Correctly installed, the filter will completely cover the face of the cartridge with the printed side facing the cartridge. To replace the filter, remove the retainer by lifting on the tab. To use bayonet attachment particulate filters on top of the cartridges, the 3M Adapter 502 is required. Align the adapter over the cartridge and engage the front snap and the back snap by squeezing the adapter and cartridge together. You should hear a click as each snap is engaged. The adapter is designed for a one-time use only. It should not be removed and reattached to another cartridge because leakage may occur. Now align the opening on the appropriate filter with the opening on the adapter and turn the filter clockwise until it stops. Be sure the filter is firmly seated on the adapter gasket or leakage may occur. These steps may be followed to attach round 2000 or 2200 series filters or rectangular 7000 series filters. The filters are easily removed by turning counterclockwise. If you have any questions about which cartridges and filters are appropriate for the respiratory hazards you encounter, consult your supervisor or trainer. Donning 6000. Before you put on your respirator, make sure the straps are pulled far enough through the buckles to permit easy adjustment. Place the respirator over your mouth and nose. Then pull the head harness over the crown of your head. Position the facepiece low on the bridge of your nose for the best possible fit and to prevent the respirator from blocking your vision. Take the bottom straps in both hands and hook them together behind your neck. Tighten the straps by pulling on the ends, top straps first, then the bottom, until the respirator fits securely but comfortably. Do not pull the straps too tight. If the straps are too tight, push out on the back of the buckles to loosen them. Always check the seal of the respirator to your face before entering a contaminated area. Donning 6000 DD. Before you put on your respirator, adjust the head cradle size to comfortably fit your head. With the head cradle positioned on the crown of your head, hold the strap ends with one hand and slide the facepiece up onto your face with the other hand. Position the facepiece low on the bridge of your nose for the best possible fit and to prevent the respirator from blocking your vision. Take the bottom straps in both hands and hook them together behind your neck. Tighten the straps by pulling on the ends, top straps first, then the bottom, until the respirator fits securely but comfortably. Balance strap tension by adjusting at top and bottom strap buckles. If the straps are too tight, push out on the back of the buckles to loosen them. User seal check. Always check the seal of the respirator to your face before entering a contaminated area. Before you enter any contaminated area, you must perform either a positive or negative pressure user seal check. To perform a positive pressure user seal check, place the palm of your hand gently over the exhalation valve cover, being careful not to apply too much pressure and disturb the face seal. Exhale gently. If the facepiece bulges slightly and you feel no air leaking between your face and the face seal, your respirator has sealed properly to your face. To perform a negative pressure user seal check with cartridges, first cover the open area of the cartridge with the palms of your hands. Filter retainers may aid in conducting a negative pressure user seal check. To perform a negative pressure user seal check with the round 2000 or 2200 series particulate filters, position your thumbs over the center of the filters to restrict airflow through the filter. To perform a negative pressure user seal check with the rectangular 7000 series particulate filters, squeeze to compress the filter. After you've sealed the filter or cartridge inlet, inhale gently. If the facepiece collapses slightly and you feel no air leaking between your face and the face seal, your respirator has sealed properly to your face. If you detect air leakage when conducting either the positive or negative pressure user seal checks, reposition the respirator on your face or readjust the tension of the straps. Then repeat the user seal checks. If you have any difficulty getting the respirator to fit, review the user instructions in the packaging or the fitting instructions provided by 3M to be sure you are putting it on correctly. If your respirator still doesn't fit correctly, see your supervisor. A user seal check must be performed every time you put on your respirator. Never enter a contaminated area if your respirator does not seal properly. Remember, a user seal check is not a substitute for a fit test. It's very important that you have a fit test to be sure the respirator is capable of fitting you properly. Your respirator may be damaged if you smell or taste contaminants, if breathing becomes difficult, or if dizziness, irritation, or other distress occurs, and you should leave the contaminated area immediately. See your supervisor and repair or replace your respirator. Remember, a user seal check is not a substitute for a fit test. It is very important that you are fit tested annually to be sure the respirator is capable of fitting you properly. Removal 6000. To remove the respirator, unhook the lower straps using both hands and pull the head harness over your head. Removal 6000 DD. To remove the respirator, unhook the lower straps using both hands, then slide the facepiece down the straps to your chest. Replacement and cleaning. Replace the particulate filters according to instructions provided by your supervisor, or when they become soiled, damaged, or breathing becomes difficult. Replace the chemical cartridges in accordance with your workplace's established change schedule, or earlier if smell, taste, or irritation from contaminants is detected. Clean the facepiece between uses by removing cartridges and filters and immersing in warm cleaning solution. Do not clean with organic solvents, which may degrade some respirator components. Make sure the water temperature does not exceed 120 degrees Fahrenheit. Scrub with a soft brush until clean. Add neutral detergent if necessary. Do not use cleaner containing lanolin or other oils. Disinfect the facepiece by soaking it in a solution of quaternary ammonia disinfectant or sodium hypochlorite or other disinfectant. Rinse the facepiece in fresh, warm water and air dry in a non-contaminated atmosphere. 3M respirator wipes may be used as an interim method in the cleaning schedule for individually assigned respirators, but they must not be the only method in place. When not in use, store your respirator in its resealable storage bag or other suitable storage container away from the contaminated areas. 6000 replacement parts. To remove the respirator strap assembly, pull the upper legs from the facepiece buttons. Pry the valve cover assembly from the facepiece exhalation port. To replace the respirator strap assembly, position the valve cover over the facepiece exhalation port and press firmly to snap it into place. Push the upper legs onto the facepiece buttons. To remove an existing exhalation valve, remove the respirator strap assembly as you did before. Grasp the valve and pull it off the center post. Inspect the valve seat to make certain it is clean and in good condition. To replace the exhalation valve, place the new valve over the exhalation port. Insert the stem into the center hole and press firmly on the valve. Make certain the valve is fully seated and spins freely. If the valve does not spin freely, push on the valve again until the stem is fully seated in the center hole. Replace the respirator strap assembly as you did before. To remove an existing inhalation valve, grasp the valve and pull it off the center post. To replace the inhalation valve, press the whole of the valve over the center post on the valve seat. Be certain the valve is fully engaged through the valve post and lays flat. The two red gaskets are designed to seal the interface between the facepiece and the filters, cartridges, or dual airline. They should be inspected before each use and replaced if lost or damaged. When installing new inhalation gaskets, make certain they are in proper position under all three bayonet lugs. Understanding how to properly and safely use, maintain, and secure your respirator is of utmost importance. Don't forget that the user instructions are included with the respirator. And remember to always ask your supervisor if you have any questions regarding respiratory protection.
When to use supplied air respirators. Some tasks always require supplied airline respirators. These tasks include IDLH atmospheres, sandblasting, painting with certain paints or epoxies, welding on lead containing materials. Oxygen-deficient atmospheres are considered IDLH, and use of supplied airline respirators or self-contained breathing apparatus are required to enter these areas. Oxygen deficiency can occur in confined or enclosed spaces, during fires, or large chemical releases. Normal air contains 21% oxygen. An area with oxygen content below 19.5% is considered oxygen deficient. Only a SARS or SCBAs can protect against the effects of oxygen deficiency on a worker. Here is an example of a gas that can be IDLH, hydrogen sulfide. Hydrogen sulfide gas is the off-gas of decaying organic material. It is commonly found in sewers. It can be instantly fatal at higher levels in a confined space, the IDLH level being only 100 parts per million. Rescues in sewers typically require SARS or SCBAs. Airline respirators work by getting air supplied from outside the workspace. The air in the space is not filtered. It is provided by a compressor or tank. Only tight-fitting facepieces can be used in IDLH atmospheres. Continuous flow is found in loose-fitting airline respirators, which can be used for certain non-IDLH work. The maximum hose length for a supplied airline respirator is 300. Workers in IDLH conditions using airline respirators need 2 rescuers on standby, unless one worker can safely perform a rescue. Supplied air respirators should have different ways of getting you air. Air pressure inside a supplied air respirator facepiece is controlled by the respirator regulator. Pressure demand means air flows into the facepiece as needed, but the facepiece is always positively pressured. Demand means air flows into the facepiece only when you inhale. Only pressure demand can be used in IDLH conditions. Continuous flow respirators are for use in non-IDLH atmospheres. Continuous flow means air is constantly blowing into the respirator facepiece. Continuous flow is found in loose-fitting airline respirators. These types of respirators are more comfortable and hoods can be worn over a beard. Continuously flow respirators cannot be used in IDLH conditions. Types of air compressors that can be used for airline respirators include low-pressure compressors, sometimes called ambient air pumps, and high-pressure compressors. Low-pressure compressors must be able to provide at least 4 cubic feet per minute of air or 6 cubic feet per minute of air if working with asbestos-containing material. Their capacity is limited and may not provide enough air in IDLH conditions. High-pressure compressors have the capacity to provide pressure-demand airflow to airline respirators. These photos show compressors specifically designed for respirators. Use breathing air couplings on airline respirators that are not compatible with couplings for non-respirable air or other gas systems. This will avoid accidental connection to a system that was not designed for breathing air. The air coming to the respirator facepiece is crucial. Compressor or tanked air must be filtered with a system that can make it what we call grade D air. These are often called breather boxes in the field. Grade D air is between 19.5 and 23.5% oxygen. CO less than 10 ppm, an alarm must sound if carbon monoxide is over 10 parts per million. CO2 less than 1000 ppm, condensed hydrocarbons less than 5 milligrams or centimeters. Water vapor less than 66 ppm, and it must have no objectionable odors. Breather boxes must be maintained according to the manufacturer's instructions and tagged that are in service by an authorized person. Maintain your supplied airline respirator systems. Follow the manufacturer's recommendations for all maintenance activities. Clean as needed before storage, especially the inside of the facepiece. Store facepieces and regulators in a clean, dry place. Coil up hose and store in protected area to prevent damage. Inspect facepiece and hose for damage and replace as needed. Keep replaceable spare parts available that are not compatible with couplings for non-respirable air or other gas systems. Tag damaged respirators to prevent use. When to use supplied air respirators. Emergencies involving respirators may occur. You should have a plan of when and how to exit an area when wearing a respirator. If you experience any of the following, you should leave your respirator on and immediately exit the area. You taste, smell, or feel chemicals entering your facepiece. If it becomes difficult to breathe, you start to feel ill, dizzy, develop a headache, cough, or irritated throat or eyes. Your respirator breaks or loses seal. Check your air monitoring, engineering practices, respirator fit, cartridges, and filters before going back to the area. When you must enter an area with an IDLH atmosphere, you must use either a supplied airline respirator, sometimes called a SAR, or a self-contained breathing apparatus, commonly called a SCBA. When entering an IDLH atmosphere, there must be at least 2 standby rescue employees outside the area. Only one standby employee can be used for rescue if the IDLH condition is well characterized, will remain stable, and you can show that one employee can adequately monitor employees in the area, remain in communication, and initiate rescue duties. To receive certification for this course, you must do the following. Pass the respiratory protection test. Complete the medical evaluation survey and have it reviewed by a medical professional. Be fit tested for each model of respirator you will use and complete the fit test skills sheet. It needs to be signed by our qualified fit tester for you to be authorized to wear a respirator at work. You have completed the online portion of this training.